Hi everyone, finally the moment has arrived for us to discuss the very important topic of beta oxidation. For what we were setting up this entire topic, finally, we're discussing beta oxidation. The beta oxidation is basically, as we've already established, we got fatty acyl CoA. After so much hard work, we finally managed to get it inside mitochondria. So this entire beta oxidation, where is it happening? It's happening inside the mitochondria. Now, fatty acyl CoA it's going it's going to undergo beta oxidation, and there are four steps, right? And they all are repeated over and over again depending upon the number of carbons of the fatty acid. So first step first, you will have oxidation that produces fatty acid. Sorry, oxidation that produces FADH2. So this is your first reaction. The second reaction is hydration because the water is being added. The third reaction is again oxidation, but this time it produces NADH. And the fourth reaction is basically thiolytic cleavage, which is dependent on CoA. So CoA dependent thiolytic cleavage. So this is your fourth reaction. So these are the four reactions of your beta oxidation. So you just need to know the steps. The first is oxidation that produces FADH2. The second is hydration. The third is oxidation that produces NADH, and the fourth is CoA dependent thiolytic cleavage. Finally, this is what is happening. Now, what are the products of this one cycle? This is one cycle, right? So, what are the products? You are getting one FADH2, you're getting one NADH, and you're getting one acetyl CoA, right? Now, I'm going to tell you a very important formula that should be on your fingertips, which is N by 2 minus 1. So, with the help of this, you can calculate that how many times do you have to repeat this cycle, this four-step cycle of beta oxidation over and over again, number of depending upon the number of carbons. So for example, if there is, let's say we had the palmitate, right? So for the palmitate, which is palmitic fatty acid, the number of carbons are 16. So 16 by 2, let's do the maths. This makes 8, and then you have to minus it from 1. So you'll get 7. So this is the number of times that this cycle has to repeat over and over again. So 7 times this reaction will repeat. So that means if it's repeating 7 times, you're getting 7 NADH, right? We're talking about palmitate right now. And you will also get 7 FADH2, and then you'll get 7 acetyl CoA. But there's one fun fact. The final cycle, which is the seventh cycle, in that what will happen? You'll actually get two acetyl CoA. Now you may be wondering why is it so? Because you can already see that when you undergo a thiolytic cleavage, so basically you'll have fatty acyl CoA and you'll have acetyl CoA. But by the time you reach the end of this beta oxidation, you won't have a fatty acyl CoA. You'll just be left with two acetyl CoA because all the acyls or all the hydrocarbon chain it has finally finished, and you're left with acetyl CoA, right? So that is about 2 acetyl CoA in the last step. So therefore, 7, yes, every step had one acetyl CoA, but the final step it had one extra because I told you it has 2 acetyl CoA in the final step. One is already included in this formula. So finally, in the last step, you had one extra. Therefore, the total is 8 acetyl CoA in the last step, right? So this is the entire calculation. So our entire calculation will be based on this. Sorry, it's getting slightly messier. I'll rewrite it. But yeah, this is the diagram you can see. 17 is you have 16 carbons of palmitate. We did the math and we figured out that you need 7 FADH, you need 7 NADH. But when you talk about acetyl CoA that is going into TCA cycle, you will have 8 of them because the last step you can see this is the last step. It has 2 acetyl CoA that are going to go into TCA cycle, right? And when you talk about every like this part, and oh my god, I forgot to mention the most important part, which is that in every beta oxidation reaction, even though there are four steps, right? But what happens that two carbons are eliminated, and these carbons are from which end? These carbons are from the carboxylate end. So from carboxylate end, the two carbons are eliminated each time. Now this means that this will keep on happening dependent on this formula. And for example, if I'm talking about going down this step from 16 carbon to 14 carbon, there are the four steps that are occurring in the middle. So this is oxidation that produces FADH2, this is hydration, this is oxidation that produces NADH, and then finally you have the thiolytic cleavage, which is CoA dependent. Now when you're calculating your energy yield, it's very important for you to know that how much ATP is going to be produced by FADH2, NADH2, NADH, and then per acetyl-CoA, how much ATP will be yielded. And how do you get this ATP? So basically, what happens is that these reduced coenzymes, what are the coenzymes that I'm referring to? FADH2, NADH, and your acetyl-CoA. These reduced coenzymes, they are going to be oxidized by the electron transport chain, especially these two reduced coenzymes particularly. These are oxidized by the electron transport chain. And in ETC, particularly complex 1, it oxidizes NADH, and your complex 2, complex 2, I got a little bit distracted. Coenzyme Q, it is going to, what do you call it? It's going to oxidize FADH2. And per NADH, how much ATP are you going to yield? 2.5. And per FADH2, how many ATP you're going to yield? 1.5. And per acetyl-CoA, how many ATP are you going to yield? 10. So these are the numbers that you need to memorize, right? This is the information that you need to know, that per FADH2, you're going to get 1.5 ATP, per NADH you're going to get 2.5 ATP, and per acetyl-CoA you're going to get 10 ATP. So these are some statistics that should go in your mind. And other than that, that formula was very important, n by 2 minus 1. So 16 by 2 minus 1, 7. Good. So when you talk about 7 NADH, let's begin with this reduced coenzyme. 7 NADH, this means this number will be multiplied by 2.5, and it's going to give you a certain value, and then you have your how many FADH? 2. You have 7 FADH2, which are reduced coenzyme, and this is going to be multiplied by 1.5. So it's going to give you a certain amount. And then how many acetyl-CoA were we dealing with? So 7 in total, but then in the last step we had 2, therefore 8 acetyl-CoA, and these are going to be multiplied with 10. Thankfully, this is an easy math that we can do. For the rest, we'll need calculator, and I've already calculated and kept the values. So 10.5 and 17.5. So 17.5 from here and 10.5 from here. When you add this entire value up, so 80 and 10, 90, and then you have then 100, and then how about this? This is 108. So 108 is your total ATP that you're going to yield. But hold on for a second, because um, when you talk about activating fatty acids, so I told you, right? Fatty acids, they need to be activated with the help of synthetase, that thiokinase enzyme. So there, if you recall that reaction, you'll notice that you have to use 2 ATP. So let me deduct that 2 ATP, and now this is your net energy yield, which is a lot. So this is about the energy yield to the entire reaction. And yes, here ATP is needed for this, so therefore 2 ATP will be used. And yeah, this is your final energy yield, 106 ATP for your palmitate. Now you should be able to calculate energy yield per reaction.